in solving some jump question. Now, the one here we are given that a load of 5 Newton gives an extension of 0.56 centimeter. Firstly, we are given a load. Now, be careful here. The load here can also be referred to as a force, and that is given as 5 Newton. And from there, we are given an extension. And the extension of the load was given as 0.56 centimeter. The question goes on by saying, in a wire which obeys Hooke's law. So when you hear Hooke's law, they're referring to the one that says your F is equals to your KE. Put that in mind. What is the extension cost by a load of 20 Newton? So you're looking for the extension again, that will be cost if you apply a load of 20 Newton. So that means you have another load. I told you this load is also referred to as a force, and that is what 20 Newton. Looking at this case carefully, we observe that we are given two loads and we are given two extensions. So that means this should be our F1, this should be our F2, this should be our E1, and this should be our E2. So how can we relate this F1, F2, E1, E2 to Hooke's law? Considering our Hooke's law, we say Hooke's law is F is directly proportional to your extension. So if you want to get the relationship between your force and your extension, what are we supposed to do? We need to divide both sides by the extension so that we can have the constant K having itself standing alone. So we have as F all over the E. This you are seeing is the relationship. We call this relationship. Now from the relationship, you cannot derive the formula that says F1 all over your E1 equals to F2 all over your E2. So that means the force and the extension, the force and the extension. So that's that on that. And that's the formula you have to use. Or sometimes you can try to cross multiply. If you don't want to use that, you can just cross multiply from here. When cross multiply, you're going to have that F1 E2 equals to F2 E1. So this is also the formula you can use for your relationship between your force and extension. Now let's go on to the parameters given to us. From the parameters given to us, we are given the value for F1. Our F1 is given as 5 Newton. Likewise, F2 is given as 20 Newton. While the extension, our E1 is given as 0.56 centimeter. On and off, you will be asking me that, okay, why did I convert this to my meter? The reason because if you observe our answer at this case is left in form of centimeter. So I don't need to bother changing that to my meter. You get it? Because the answer is left as centimeter. Had it been the answer is left as meter, I would have made sure I convert this to meter. But since the answer is not left in meter, I don't need to convert that. So we are given our E1 as 0.56 centimeter. Then our E2, which is the other extension, is what we have to look for. By the formula I gave you, we said F1, the first one I gave you, F1 over E1 equals to F2 over E2. Now, what's the value for your F1? Your F1 is 5 Newton. You have 5 all over. Your E1 is given as 0.56. So put here as 0.56 equals to your F2. Your F2 is given as 20 Newton. So here's 20 all over your E2 is what you are asked to look for. So in this case, what you just need to do is to cross multiply. When you cross multiply, you have 5 times your E2 equals to 20 times 0.56. 0.56. So in this case, you know you are looking for the value of your E2. What you just need to do, I will advise you to divide both sides by your 5. Divide both sides by your 5 immediately so you can cancel this. And when you cancel this, you're going to have that your E2 will be given as 20 times 0.56 all over your 5. With the help of your calculator, you can get the value of that. So 20 times 0.56, and that gives you 11.2. Then you are going to divide that by 5, and that gives us 22.24 centimeters. So therefore, our E2, which is the new extension, is 2.24 centimeters. As you can see, it is less in centimeters. So let's confirm whether we have such option in our or such answer in our option. Coming here, we are given, okay, so we have the answer here, which is 2.24 centimeter in our option. As you can see, it's a exam question 1987. So let's solve more question on this. Solving another question on this. Okay, so solving another question, which is our grade 2. In this question, we are given that a spiral spring extend by 5 centimeter. So we are given the extension. Okay, let's assume it is the same question given to us, which is 5 centimeter, our A1. Under a load of 60 newton, this is our F1. I told you whenever you are giving your load is also referred to as what? Your force. So that is given as 60 newton. When the load is replaced by a steel block, the new extension, as you can see, we are given the new extension. Let's call that one our E2. The new extension is 7 centimeter. So the new extension is given as 7 centimeter. It has also the weight of the steel block is the weight of the steel block, which is W, and now your weight is also measured in newton. So that's still defined to the force. I'll call this one F2, and that's the question you have to find. The last time I told you how you can get the relationship. F equals to KE. Since they're only comparing your force with your extension, you're going to have that our K equals to F over E. Don't forget, this is gotten from Hooke's law. Now that we've gotten that this is it, then we are going to apply the relationship formula. The formula for this relationship can be given as F1 over E1 equals to your F2 over your E2. So in this case, I'm trying to get the value for my F2. So what I need to do, I just need to cross multiply. When I cross multiply, I have that my F2 times my E1 is equals to F1 times my E2. And you know, you're already given that our F2 is what you are looking for. Then we are given our E1 as 5 centimeter, our E2 as 7 centimeter, then our F1 as 16 newton. Just put that there. So my F2 is what I'm looking for. I'm multiplying it by my A1, which is given as 5 centimeter, and equals to my F1, which is given as 16 newton, times my E2, which is given as 7 centimeter. Now you'll be asking me, sir, you didn't convert the meter. I didn't convert my centimeter to meter. Now, most of you are dealing with jam, and in jam, you have to work smart with your time. In this kind of situation, since the both extensions are given in centimeter, you don't need to convert. Just go straight to the point. You're still going to arrive at the same answer. But in case whereby you're having this side as meter and you're giving this side as centimeter, you need to convert your centimeter to meter, or you convert your meter to centimeter. You must make sure that you have the same unit. So that's what I'm going to tell you about that. So let's move on. What are we going to do? We are going to cut all through by your 5. When you cut all through by your 5, since you're looking for our F2, so I have to be given by 60 times 7. With our calculator, 60 times 7, that gives 420. So divided by, okay, sorry for that, 60 times 7, that's 420. You are dividing it by 5, and that gives us 84. So yes, 84 newton. So the other weight or the other force is given as 84 newton. Let's consider the answer here. Okay, we are given the answer as option C. Option C is the right answer. Moving on to the next question, which is our derivative.